Bonjour, students. Today we're going to talk about functions. Now, what does it even sound like? Well, how something functions is how something works. So let's think about it that way. How does something work? And especially, how does it work when you talk about numbers and variables? Now, what we're going to do is we're going to think about the idea of an input, something going into a machine. And once it's in the machine, it's doing some type of work. And when it comes out, that's what's going to be our output. So what we put in creates something coming out. We're going to think about a couple ideas, just that idea of an ordered pair, an x value and a y value. Remember, it's called ordered pair because the x is always first and the y is always second, and it's called a pair because a pair means two. We also use the word coordinates for the x and y, and that's most likely when we are graphing. We would use coordinates. So what we're going to do is we're going to put inputs. Now, let's say -1. We're going to put the input of -1. Something is going to happen in here, and we're going to get an output of 5. Okay? This is the idea of a function. Have you heard of this before? Absolutely, because you've heard of an equation before. A function and an equation, for the most part, are the exact same thing, okay? And we can see that by, when we write equations like y equals 2x plus 3. And we're using the variable y. Now, when we're going to be writing functions, we're always going to be writing them with the idea that we're going to have an f of x. All the f means, it's just the name of the function. You could write your function name as math, okay? And what's in the parentheses is going to be the input. Let's say for the input of math, you wanted to use the variable a for apples. So this would be the function name. This would be the input. So that's really all it is, okay? They use the f probably because it's called a function. That just makes a lot of sense. So we have inputs, we have outputs. Another name for inputs and outputs is the domain and range. Domain will always be the x values, okay? And the range will always be the y values, okay? Inputs are the x values, and the outputs are the y values. And that's really all there is to it. All right, let's take a look at something called the function rule. Now, the function rule, just like what we talked about, if we have y equals 3x plus 7 and f of x equals 3x plus 7. You can see that these are exactly the same. So what we would think of as an equation and what we would think of as a function, really essentially the same thing. And the key to this, though, is the y is the output and the f of x is the output. That's what we're going to think about. Now, our input, right, what we're putting in is going to be, this x value. That's very, very important. So the x is the input. The y and the f of x will always be the outputs. And how would you read this? This one right here. Read it as f of x is equal to the product of 3 and x plus 7. So the key to this is f of x. That's how you read a function. Okay, moving on. The example we're going to use this chart right here. All right. I call it like a function chart. And what it's going to do is it's going to show us the x values, right? These are going to be the inputs. That's what we just talked about. The x value is the inputs, or the input, and the y value is the output. So we're going to look at the relationship between x and x squared. Really, what does this mean? Well, if we have y equals x squared, this is the output, this is the input, we're going to write it as f of x equals x squared. So whatever we put in for our x, we're going to get our output, our input and output, x. So here we have a 3. If we put a 3 in for the x, we'll get 3 to the second power, and that, of course, is 9. And that's all that's happening here. And you can see our little chart up here. It shows us some pictures. And then if we draw this chart down here, it'll actually just show us the inputs on this side, the outputs on this side. So there are many ways to think about this, look at this. The very, very, very important thing. It is a function because of what I'm about to say. Every element in x is related to y. So if you have any output, 3, 1, 0, 4, -4, they all have to produce one output. I may have misspoke. If you have any input, every input has to produce an output. Also, no input has 2 or more relationships. Really, what does that mean? Every input can only have one output. Only one output, okay? Only one output. That's very important, okay? Now, an example here, though, here's one input. So this input has one output, 16. This input, -4, has one output, 16. But you can see that they're exactly the same number. That is okay. The key, though, is that each one of these inputs only has one output. It can be the same output, though. All right, let's take a look at this. Now, this is already telling you it's not a function. So we have to figure out why. Well, let's take a look at this drawing. We have our inputs and we have our outputs. What we just talked about, though, every input has to have an output. And what you can see is that the 4 and the 3 do not have outputs. So right off the bat, this is not a function. It absolutely has to have, every input has to have an output. The second thing I want you to see is this one input has 1, 2, 3 outputs. That cannot happen. So in a relationship, it is not a function for these reasons. Value 3 in x has no relation in y. Value 4 in x has no relation in y. That's what we talked about. And value 5 is related to more than one value in the outputs. So there we go. The last thing we had to decide, are these functions? Well, I'm going to show you something. There's a test we can use, but I'm going to explain it to you, and then in the end, I'll just kind of tell you the rule. Now, for every value of x, there should only be one value of y. So if we come up for this value of x, -2, we only have one value of y. If we come up for this value of x, we're going to have only one value of y. Same thing here. Same thing here. This is a function. Okay? For every value of x, remember, these are the x values, there's only going to be one point on this line. For this graph, right, for every value of x, so if we draw a line from our x, no matter where we draw the line from the x, there's only going to be one point on the line. Or, in other words, there's only going to be one y value that goes with this x value. So yes, this is a function. Same thing here. We draw some lines up. There's only one point on the graph line. So yes, this is a function. Now, if we get into this drawing, let's take a look here. If I pick the x value of -2, okay, and I draw a line, how many points does this go through? It goes through the line at 2 different points. So the answer is no, this will not be a function. Okay? This will not be a function. And in the end, right, that's called the vertical line test for functions. So really what's happening is you're just drawing lines. If it only goes through one point on the red line, it is a function. So yes, yes. Now this one, right, if you draw a line coming down here, well, it's going through many, many points on this line. So not a function. For this one, still only one point, so function. And then when we get into this, right, it's going through 2 points, not a function. This one, function. This one, you can see it's going to go through more than 1 point, not a function. And even if you have a circle, if you draw that line going down, it goes through more than 1 point on the circle, so not a function.